All right, guys, so this is part 2 of reference angles. And before we start, I want to take you back to the part 1 for a second. And let's just remind ourselves, what is a reference angle? So I'm here at this part looking at the definition. What's a reference angle? That's the angle formed by the terminal side of theta and the x-axis. So again, also we'll be referring to the reference angle using this symbol right here. And that is theta prime. So if we're looking here maybe at this example, we might see here that this is theta right here. This is the angle that's created, but your reference angle is this space here. What's the angle here that lives from here to here? Okay. So I want to know what's this theta, and that's why I called it theta prime. So that's our reference angle. Now, we practiced these last time, but we only did degree examples. And so today we're going to be focusing on those in radians. So I have here that the objective is I'll be able to sketch angles and find reference angles of radian measurements. I threw on here the graphs from the last notes, just in case you don't have those for some reason, and so that we can easily refer back to that. All right, so let's get into some examples here. The first example is 5 pi over 4. The goal is to sketch and find reference angles. Now, I know I never really taught you how to graph in radians, and so we're going to, before we jump into this, pause for a second and do some side notes over here. There's some important ways that, this is just my way of trying to better understand how to graph this or how to think of it when you're graphing in radians. So there's some really important things that I like to just write on my paper every time. Whenever you see any kind of pi over 6 radian, they're always referring to some kind of combination of 30 degrees. Okay, so then whenever you see pi over 4 radians, they're always referring to some type of 45-degree angle. And whenever you see pi over 3, they're referring to a 60-degree angle. Now, there's no number in front of these. This is pi over 6, pi over 4, pi over 3. Because, and when I meant no number, if you look at our example here, there's 5 pi over 4. Well, there's always the original ones here. They have an invisible 1 in front. So I like to think of these as 1 pi over 6, 1 pi over 4, 1 pi over 3. Now let's focus on this one here. This is the best example because 45, it's easier to think in 45 degrees. So now let me graph 1 pi over 4. Okay, 45 degrees is half of 90. So that's half of this area here. So I'll draw a line right in half. Okay, so I know that this radian measure is 1 pi over 4. Now, where would 2 pi over 4 be? Well, I would have to go another 45 degrees. So from here to here is 45. From here to here is another 45. So at this point right here, this would be 2 pi over 4. Let's keep going. Where would 5 pi over 4 land? Well, I know I need to go another half because it's 45 degrees that I'm talking about. So another half, this would be 3 pi over 4. Another half, we'd land here. This would be 4 pi over 4. And I know that you're like, wait, can you have that? No, that's actually going to simplify. And this is pi. We've already said this before. And then go another half, and there is 5 pi over 4. So you'd go another half, here's 6 pi, you go another half, there's 7 pi, over 4, 8 pi over 4, and so on. So you can keep going around and around and around and around and around, and you can count up to, 20 pi over 4, or, any combination of that, as long as you just keep going. Let me graph 5 pi over 4 over here, just so it's nice and neat. So I said, I'm going to start here. And 5 pi over 4 landed over here. because we had half, half, and then half. This was 1, 2, 2, 3, 4, 5, right? So I don't need all these, but this is, how I ended up there. So this is theta equal to 5 pi over 4. Now I landed in the third quadrant, so I'm going to come back up here and check my rule. How do you find the reference angle of an angle that landed in the third quadrant? That is here. Subtract pi from theta. So our theta was 5 pi over 4. Subtract pi from that. And I know that I need to have a common denominator. So each item over here is going to be multiplied by 4. I end up with 4 pi over 4. Subtract 5 from 4. That's 1. So I end up with just pi over 4. That's my reference angle. Let's do another one. And we'll change up the angle measurement that we were referring to over here for the side notes. So now we're working in 5 pi over 6. So now we're working with pi over 6 angles, which is 30 degrees. But 5 30-degree angles. That's how I like to think of it. Graphing these kind of takes practice. So I'll start here. And one 30-degree angle, that's about here. And another 30-degree angle goes about here. And so if you think about it, I can make this a little neater. If you think about it, this is 90 degrees, right? How many 30-degree angles live in the 90-degree angle space? 3 30-degree angles. 3 times 30 is 90. So we would say maybe I like to just draw it out at first to kind of practice. So from here to here, that is 1 pi over 6. From here to here, that's 2 pi over 6. Then from here to here, that's 3 pi over 6. And then you keep going until you hit 5 pi over 6. So I'll do another 30 degrees. So from here to here, that's another 30 degrees. And maybe you're like, wait. Why is it 30 degrees? Because remember that pi over 6 up here in my side notes refers to 30-degree measurements. So this is 4 pi over 6, another 30 degrees from here to here. And there's my 5 pi over 6. Just for fun, really quick, from here to here, another 30 degrees. That's going to be 6 pi over 6. And remember that cancels out and you end up with pi. But what we really needed here was this 5 pi over 6. So which quadrant did you land in? I landed in the second one. So let's go back up. The rule for the second one is take pi and subtract theta from it. Now, you don't need to draw all of these angles here. I just did it now to kind of show you guys a practice of how I graph this. So the rule was to find your reference angle, subtract pi from theta. Oh no. Oops, second. The pi minus theta. Pi minus theta, which was 5 pi over 6. I need this common denominator to be 6, so multiply each item times 6. That's 6 pi over 6 minus 5 pi over 6, and you get pi over 6. That's your reference angle. Work, period 2 and 6. I'm just going to have you guys both submit these because Delta Math has no radian examples, and so for today's assignment, both periods will complete this and turn it in on Schoology. See you guys on the next one.